Okay, welcome to Foundations in Pre-Calculus Math 10 with Mr. Johns. We are going to start section 5.6, and first we'll do a skill builder and then move on from there. So the first thing we're going to do is create a table of values for an equation. And we'll substitute values of x into the equation to solve for y. And basically this is the function machine. Is we put in x's through the machine, we get out y's. And so if we look at this example, they're putting in negative 2. 4 times negative 2 would be negative 8. Minus 3 would be negative 11, and that's our y value. If we did the work in the head as x's go in, then y's come out, and this is our function, y equals 4x minus 3. So, sometimes the equation will be quite simple, where no matter what we put in, we get a 3, and other times, if we can only put in a single x value, we'll get all different y values, which would be just a line. So for number 1 here, we're asked to use the function y equals 3x plus 4, and we're supposed to use all these x values. So 3 times negative 2 plus 4, which would be negative 6 plus 4, which would be negative 2. 3 times negative 1 is negative 3, plus 4 is 1. 3 times 0 plus 4, so 0 plus 4 is 4. 3 times 1 is 3, plus 4 is 7. And if you notice, each time we go, it's going up by a certain amount. 3 times 2 would be 6, plus 4 is 10. So each time we go up by a value of 3. Go ahead and try B on your own. Okay, so now we're going to talk about properties of linear relations, and to do this we're going to talk about various types of equations. So we can find patterns in a table of values. A linear relation would create a straight line, and what's happening here is every time x goes up by, in this case 2, y is going up by 6. And this even incrementation makes a straight line. So I'll let you go through example 1, deciding whether a table of values represents a linear relation, and I'm going to do this check number 1 with you. So here, from 0 to 5 is a difference of 5. From 5 to 10, we're going up 5. And then 15 minus 10 would be a difference of 5. And 20 minus 15 would be a difference of 5. So the x values are going up evenly. Now the question is, are the y values? This would be 3. 24 minus 21 is 3. 27 minus 24 is 3. And 30 minus 27 is 3. So the changes in the first column are the same. The changes in the second column are the same. So this relationship is linear. Go ahead and try B on your own. So when a graph of an equation lies on a straight line, the equation represents a linear relation. So this is a linear relation, and this is not a linear relation. Example 2 says deciding whether an equation represents a linear relation. So I'll let you go through example 2, and I'm going to do the check value with you. So does each equation represent a linear relation? So this one, they give us y equals x squared minus 1. And we're going to use a table of values like we learned in the skill builder. So here, we'll put in x squared. We put in negative 2 for x, and we'll get 4 minus 1 is 3. Negative 1 squared is 1 minus 1 is 0. 0 squared is 0 minus 1 is negative 1. And you'll notice right away this went down by 3, this went down by 1. And so now I have 0 again. And so the changes are inconsistent. So we have some type of relation, but it is not a linear relation. So if I was to plot these points, I would use them as ordered pair, like this pair would be negative 2 and 3. So we go negative 2 and 3 up, negative 1 and 0, 0 and negative 1, 1 and 0, and 2 and 4. Now I could put in any other value, so I will connect these with a curved line. And so this is a relation, and it's called a parabola, but is not a linear relation. Do the points lie on a straight line? No. Does this represent a linear relation? No. So go ahead and try this one. So we've seen that linear relations involve variables changing at a constant rate. We can find this rate of change of a linear relation. The rate of change of a linear relation is the fraction where we have the dependent variable, which is often thought of as y, over the change in the independent variable, which is often x. The dependent variable is plotted on the vertical axis, which is y, and the independent variable is plotted on the horizontal axis, which is x. So now we're going to find the rate of change from a graph. So looking at this one, the graph shows the altitude of a helicopter as it descends to land. Identify the dependent and independent variables. So the dependent variable is plotted on the, we'll say vertical axis, because it's the y one. And in this case, it is the altitude. And the independent variable is plotted on the horizontal axis. And it is t, the time. So the rate of change, change in altitude, goes from 0 all the way to 360. So we're going to find the rate of change, and what does this represent? So we're going to talk about from this point to this point, the rate of change. So we go from 0 to 180. And this represents a negative 180 meters. So they went down 180 meters. The change in time is from 120 to 60 seconds, and this is a difference of 60 seconds. So we want to talk about change in the dependent variable over change in the independent variable, which is the change in altitude over the change in time. So in this case, we have negative 180 meters over 60 seconds, and this is negative 3 meters per second. So the rate of change is negative 3 meters per second. This is negative. So every second the helicopter descends or goes down 3 meters. And this is the rate of change. For your assignment today, I'd like you to do all of number 1, all of number 2, number 3, 4, A, but don't do B, and then number 5, but don't do number 6. So everything except 4B and 6, please.